Can you guys see my screen? Yeah. So again, many of you got the question wrong, I think. Okay. So what we will do is like first understand the question, then go for solving the question. So let me just get the question. So this is a question, right? You can see that the case study is saying that Mr. Tony Stark has recently invented a technology that can make teleportation of an object from one place to another. Now he has figured out that teleportation is all about transfer of information from one place to another. So he used 2 million CPU cores. So what is given in the question? Number of cores he used is 2 million CPU cores. And all these cores he is using in parallel. Now he found that every 2 gram of mass occupies CPU cores for 45 seconds. Okay. So time it's taking is 45 seconds for these 2 million CPU cores for transferring 2 grams. Now he got an idea teleporting living things from one place to another place without killing them in the process. So he asked someone to help. They did not help. Now he wants to optimize the cost of sending an organism 5 grams. Okay, you know that organism can only survive for 135 seconds. So in the last year he told us we have to find out the possible options for resource optimization if the speed of one. So he told that one CPU core speed is 5 gigahertz. So these are the this is the information we are given. Now what is the main information here is 5 gigahertz. Okay, what does it mean is like 5 GB per second one CPU core is taking. Okay, now we are having so let's say we know that it is taking 45 seconds. So For 45 seconds, what will be the memory for each core? 45 times 5, right? Which will be equal to 225. Till here, anyone has any doubt? Now we are having 2 million CPU cores. So there are two ways to solve this problem, okay? But we want to optimize the cost. So always CPU cores will cost a lot than RAM. So what we will try to increase is RAM or CPU. Brandon,
CPU?
no, if he gets more CPU cores, that means he has to pay more, right? So RAM is at lesser cost than CPU always. So RAM costs less than the CPU. So if you can trade off getting more RAM, then that would be better. So now what we have is that we know that 225 GB is being used for 45 seconds by each core. Okay. And this is able to transfer 2 grams. Okay. Now for 4 grams, what you can do is increase the memory to times 2, right? So this will be able to transfer, which will be nothing but your 450 GB per for 45 seconds can transfer how much? 4 grams. Now for 5 grams, what would be the optimal? Helen, what will be the answer for 5 grams?
I'm not sure.
Brandon, what will be the answer for 5 grams?
Not sure.
So what we know is that now 225 GB is required for 2 grams. Okay. So 225 GB is required for 2 grams. So for 5 grams, it will be nothing but 5 into 225 divided by 2, right? So 5 for 5 grams.
$90?
It will be more, right? 222 like divided by 2. So it will be in decimals actually. So this will be 112.5. Okay. So this, if you calculate, you will get the answer. Somewhere about 562.5 or something will be the answer. So still, is this optimized solution, or can we optimize it more?
Yeah, no,
Yeah.
exactly following. I get the part how we converted the 5 GB per second to 1 CPU, but I don't really follow how we got to that 560 RAM gigabytes of RAM.
See, now you know that 5 GB is for 1 second. Okay. From 5 gigahertz, right? Now we are having 45 seconds, right? That means it is fully occupying. Then only, like, each core is fully occupying these 2 grams. Okay. And that is for 45 seconds. So from here we know that in the 45 seconds we'll get the whole RAM. Like, what is the RAM occupied, like RAM in the each core. Okay. So for that, what we did is like 45 times 5. Sorry, 5. You have 5, okay, and you have 45 seconds. So 5 GB per second for 45 seconds. How much it will become? 5 times 45, right? Till here it's clear.
Yeah.
Now what we know is like this is for 2 grams. Okay. So here what we know is that this is for 2 grams. Okay. Now if I double it, 225, if I double it, okay, it will become for 4 grams, right? So now we know that if you're doubling it, it's for 4 grams, okay? Now to get to 5 grams, how much you have to do is like, it's a just normal calculation, right? So we know that 225 GB is for 2 grams. For 5 grams, how much? So 5 times 225 divided by 2, right? Till here it's clear.
25 divided by 2 times 5. Okay, yeah.
This now from here we are getting the 562.5, okay, and 2 million CPU cores and 45 seconds, okay. But if we go and see the question, okay, the organism can survive for 135 seconds, okay. Now if I want to optimize it, okay, now I know that this is the RAM required, okay, but it is happening in 45 seconds, but it was not needed for us. Like, we can go till 135 seconds, right? So is this optimized solution, or should we go and reduce the number of CPU cores and get to 135 seconds?
We should reduce
So
and get to
so okay, try to reduce the number of cores and get to 135 seconds.
But why do we want to have the organism transferred for 135 seconds?
See,
We have a solution that can get it there faster.
yeah, I can increase the number of CPU cores and get it in 1 second also, right? But when it is saying that organisms can only survive for 135 seconds, that means what? Like, if you are able to reduce the cost and increase the time, it's okay, right? So if you are reducing the number of cores, your cost will decrease. Yeah, everyone try and tell me the answer. Harry, are you understanding?
No, I'm totally lost. I'm still trying to figure it out.
Okay, where
But,
you, what is the like where you are still stuck? Can you tell me?
actually, from the, I'm still trying to process the whole thing. But I should be able. Yeah, I'm still basically the whole thing. I'm still trying to figure it out, process it.
Okay.
Uh,
uh, so wherever you are having doubt, like just ask me. Helen,
A bit.
are you understanding?
Yeah, a bit.
Okay.
What I don't get is why do we have to calculate RAM and calculate CPU cores for this question?
So it is like this, okay? Let's say already he has come up with a solution, okay? And this solution was for 2 grams, okay? Now we know there are 2 million CPU cores which he is already using, okay? Now let's say he is asking for 5 grams, okay? Now 5 for 5 grams, okay? Increasing the RAM is the first thing you will do because that will like it is less costly than the number of CPU cores, okay? Now when you have already increased the RAM, okay, and you are able to transfer the 5 grams, like you don't want to buy more CPU cores, okay, you can reduce the CPU cores, okay. Now you want to transfer 5 grams, okay, but you are having a limit of 135 seconds, okay. So what you will try to do is like reduce the number of cores which you can use, okay, so that those CPU cores can be used for something else, okay. So in that sense you have to kind of like approach the question, like if someone is coming up with, okay, these are the, like this is my app configuration, okay, and my app can only kind of like uh let's say have a latency of 135 seconds, okay, and it has to transfer this much of data, okay, and these many cores it is using, and this is the time it is taking for the transfer of this much data. Now I want to transfer this much data, and I have like infrastructure limitations that I can buy RAM, but I cannot increase the number of cores of CPU. Okay. When he says that you have to come up with first a memory based solution, then if you are able to reduce the number of cores also, then it's a very good idea. So in that sense, understood, Clara?
Okay, so you're saying your solution should first optimize memory before we add cores because cores are more expensive.
Yeah, you should not add cores ideally.
Okay. But what I don't what I don't understand is when you say one CPU core is 5 gigahertz, where does the 5 gigahertz come into play?
So it is taking 1 second for 5 GB. Gigahertz are nothing but 1 second for 5 GB. So 5 GB is getting processed in 1 second. Is the frequency of processing.
Okay, so that's what it means. So if something is 10 gigahertz, then it means it's 10
GB per second.
second.
Yeah.
Oh, okay, okay. All right. I think now it will make a bit more sense. Okay.
Okay, now tell me for 135 seconds, what will be the number of CPU cores we have to use with this configuration?
I will just guesstimate, right? So if it was 2 million CPU cores for 45 seconds,
Yeah,
then 90 seconds would be 1 million cores.
yes,
Am I on the right track?
yes, yes.
Oh, okay, okay. So I just gotta work out the math a bit. Okay, so second,
Like I answer
Yeah,
with how many cores, right?
yeah. How many million CPU cores?
6 million.
No, you are increasing the number of CPU cores. We have to decrease it.
I'm I'm getting 666,666 cores for 155 seconds.
How many you are getting? So 2 million we are having. Just for others to understand. 2 millions we are having for is taking for 45 seconds, right? And we want to know for 135 seconds how much time it will take. So we are trying to increase the size, and both are inversely proportional.
So if I understand, so it takes 2 million, it takes 45 seconds to process 2 million, right?
Yes.
And then you want to know how many seconds, how long, I'm trying to figure out the 135 seconds.
Yes.
So so you want to know how many can be processed in 135 seconds?
Yeah. How many process? It's sorry. We are using 2 million CPU cores. Okay. For like when it is 45 seconds. Okay. Now I want, if I'm increasing time to 135 seconds, how many CPU cores we can decrease, and like what is the number we can get to?
Okay, so if 2 million is taking 45 seconds to process 2 million, and then you increase the time to 135 seconds, so yeah, it should divide it. So that's why I'm a bit lost.
Yeah, because
Okay.
both are inversely proportional. Like
Yeah, so
if you are,
if it's 2 million, 2 million takes 45 seconds. So 135 seconds, so it will be less. It will process
yeah,
more. It will actually process more of this. So if you times this 45, you take 135 divided by 135 divided by, I think, 45 times the 2. Maybe I'm just, okay, let me check something. Sorry.
What I'm struggling with is the reverse calculation, right?
okay.
Yeah, but I'm getting to 666,666 cores.
How much? How much?
So 666 cores would transfer in 155 seconds.
Yeah, it's almost that much only.
Okay, so a quick question. I'm a bit lost here. So I looked at it this way. Now, 2 million, it takes 45 seconds to process 2 million. So 135 seconds, wouldn't it be 6 million, as Brennan suggested? So it's if
So it's inversely proportional again. So it will become 2 by 3. Answer will be So it's nothing but as Clara told, it will be almost like 0.6666 million. So what is inversely proportional mean? That whenever you are increasing something, something else is decreasing, right? So here what is happening is that when you're increasing the number of cores, you will be reducing the time. You will not increase the time. So it will be like this: core 1 divided by core 2 is equals to time 2 divided by time 1, like Clara. Clara, you did this only, right?
You don't want to know how I calculated it, but it did not look that way.
So it is like this. Okay, so we know that both are inversely proportional. So now it's simple, like 2 divided by, okay, we don't know what is the core 2, so x will be there, is equals to, and 135 divided by 45. Now it will become 2 divided by x is equals to 45 times 3, right? Now we need to know x is equals to 2 by 3, so it will be some 0.66667. Brandon, do you understand this?
Yeah.
Dev, you're very funny. That's a very funny question or comment.
So see, now we are able to decrease the number of cores also. Now tell me, is this the optimized solution?
I would,
Mostly yes.
Yeah.
yeah.
Yes. Because the CPU core is more expensive, so when you reduce them a lot, so you're actually reducing costs. Is that correct?
Yeah. So now we are able to reduce the number of CPU cores. So 0.6666666, I don't know, million cores. Okay. And time we are taking is 135 seconds. Right. So now always what we need to do is like, again, so this is good. Okay. Now being on the edge is not a good idea. Okay. So either we can go till 130 seconds or something like 132 seconds. Okay. And like this is an optimized solution, but again we have to have some buffer for safety also, right? So yeah, so you can just go for 130 seconds, 131 seconds, which will increase the cost, maybe 0.7 or something, but but this is the optimized solution for now. Now why is this an optimized solution, Brandon?
Because you use the least amount of cores and the most amount of RAM. So with
Yeah.
man.
So it's kind of like this, right? So when the mass increased, okay, our first aim was to see how much RAM can be increased in each CPU core. Okay, and now for 135 seconds, we knew that it will survive, so we went for, okay, for from 45 to 135 seconds. We then reduced the number of CPU cores we are using. So now the cost for CPU cores is cut by how much? By 3, right?
Yeah.
Okay. Now anyone has any doubt in this question? Larry, still processing or understood?
Yeah, I'm getting there, but I think I'll watch the video again later to read the equation to get it but I think I should figure it out. I get it up to some point, but I still need to watch the video again and digest it.
Yeah.
But I do understand up to a certain point. Where I got a bit lost was how we come out. What did we do to come out with a point 0.6666? That's where I got lost. Yeah.
Okay, this is actually kind of
Right.
okay. So this you can remember as a like a normal formula. Okay, whenever like there are two kinds of things. Okay, just give me a second. So we have two kinds of relations. Okay, one is let's say if you are increasing the RAM, will the time increase or decrease?
Decrease.
Decrease.
Yeah, decrease.
Okay, why it will decrease?
Because there is now it's more faster and it's now faster because it's more RAM for it to transfer the data or to process the data. So which means it speed up the time.
And when you increase the number of cores, again time will.
When I increase at the time, they will increase.
No, time will decrease, right? Again.
Decrease. Oh, okay.
But if you are having some data, okay, if the data is increasing, okay, then you have to increase what? You have to increase the RAM. Okay. So this relation, okay, here what is happening is that RAM should be increased when data increases. Okay. Now if you see this, we are having different kinds of relations here. So what relations we are having? One where something is increasing and other thing is decreasing, and another where increasing and increasing is happening. Okay. So where there is both are increasing, okay, so it will be nothing but the relation. If you see, it is shown as x is, let's say, data is proportional to RAM. Okay, so it is like this: data, if you are having data 1 and you are having data 2, it will be equal to RAM 1 divided by RAM 2 directly. Okay, now when inversely proportional, that is reverse relation. So here what happens is that core 1 divided by core 2 is equals to time 2 divided by time 1. Okay, as this is inversely proportional, okay, we'll have core 1 and core 2 is equals to time 2 divided by time 1. Okay, because they are opposite in relation. When they are in the same relation, data 1 and RAM 1 will be equal to each other. Okay, but here core 1 is equals to will be like inversely proportional, because core 1 is against time 1 and core 2 is against time 2, because they are going in opposite directions. Okay, so this you can remember, and we use this only to get the 0.667, because we knew that core 1 had 2. Okay, and you can see that time 2 was 135 seconds and time 1 was 45 seconds, and we did not know x, which is the core number of cores in the core 2. Now what we did is just simplified this and we got the answer. So now it's clear, everyone?
I understand the individual pieces. I guess I just just need to read it again and fully digest it. I understand
Yeah,
where you're getting.
and also one
the
more
part.
thing is that still we are not in the optimized solution, okay? And there is something which is wrong, okay? See the video, okay, and tell me what was wrong and try to correct it. Okay, so this will be your way of debugging things. Where where is the solution? Why it is wrong? It is a correct solution, but there is something which can be done. Okay. So everyone understood how we got the answer? Brandon? Hello?
Yes.
Yeah, my internet was having some problem just now. Uh, so everyone understood, right? Brandon, any doubt?
Yeah, but I think after when we watch the video again, I think we'll have everything.
Yeah,
Even though I have confused a little bit, but I think I know where I'm getting confused, and by watching the video, I'll be able to.
yeah. So
Bring my.
this is how like the whenever you are getting any case study, you have to be able to solve it. So mostly it will use some mathematics and also like how you are able to decrease the cost for the customer. Now a new question, okay? So instead of let's say 2 million CPU cores, okay, Tony Stark had only.
Your screen is not shared. Not sharing your screen.
My screen is not shared. Now, now is it fine?
Yes.
So instead of 2 million CPU cores, okay, let's say we have 1.5 million CPU cores, okay, and it takes 2 minutes for the transfer to occur, okay, and the 1 gram of organism can be transferred. The organism can survive, okay, survival is fine, okay. Now what we will have is different tires, okay. So survive 135 seconds, okay, let's keep it the same. Now here the organism, he wants to sell the organism, let's say, and the organism can be sold at, let's go with like 14 USD, okay, if it is going like this, okay. Now next is survive 2, okay, which is like 90 seconds, and here the organism can be sold at, let's say, 16 USD, and we have survive 3, where the organism can be sold at, let's say, if it is 110 seconds, it can be sold at 15 USD, okay. Now for each of this, make a solution, okay, and let's say we are having the cost of each CPU core. If you want to increase the number of CPU cores, okay, let's say 3 million USD. So we'll go with 3 million. Let's say it's 300k USD. And cost of increasing RAM by 1 GB is 100k USD. Okay, and same 5 GSZ is the one CPU core. Okay, now what you need to find out is an optimal solution. Okay, to send 15 grams of organism. Okay, so here you have the cost factor also, and you have to calculate cost factor and tell me which will be the best, like will 135 seconds, 90 seconds or 110 seconds will be the best. Everyone understood the question? Hello?
Yeah, now I'm here. So, what you want to know is which will be the best way to follow?
Yeah,
Either the 135-second, the 90-second, or the 110-second.
yes,
So we have to work it out and choose the
yeah,
least expensive one, the best way to follow.
yeah.
So this is for homework?
Yeah, it is the homework.
Okay.
So, so you'll be getting more and more case studies, okay, on whatever you learn. So this is the homework, okay. So this homework needs to be submitted till Friday. I'll just give the deadline also. Okay, and you'll get more assignments, okay. From today, this is like only case study based assignment. You'll be getting EC2 based assignment also, which you have learned, and also elastic beanstalk based assignment. Okay. And please try to complete the assignments like as fast as possible. Okay. Any doubts, anyone?
No doubts. Just touching on elastic beanstalk. I don't know if I missed it in the last class, but did we finish deploying?
No, we did not finish the deployment.
Okay.
We'll be finishing the deployment in the next class, and after that you will be getting all the case studies based on VPCs and everything. Okay, you have to configure them. So again, it's all about like learning how to solve the problem. So and also like interviews are left and performance reviews are left. So we should be completing those, and then everything will be faster. So I think everyone has done the static website. I did not get the documentations from few of them. So please
The
submit the
Google,
documentation also.
the Google document for the documentation. I think last time I couldn't add my link.
No, it is like now you can add the link.
Oh, okay. All right. I'll
Uh,
add it after class.
everyone who has submitted also add your Google Docs link there. Okay. I think Brandon sent me. Brandon, add your link there so that others can see and understand like how others.
Sorry?
You have done the documentation, right, for the EC2?
Yeah.
Yeah, just add the documentation in the there is a Google sheet which I shared. In that you have to add it.
Okay.
Okay. Helen, you also do that. So now the next class will be deployment of Elastic Beanstalk, but till that time, please complete your homeworks, and you are like after this you'll be getting more and more homeworks. Okay, after like Elastic Beanstalk, like you'll be having enough knowledge to solve like real-time case studies. Okay. And like for the interviews, tomorrow is it fine for the ones who did not uh like were not available for the interviews? Clara,
Yeah, I think tomorrow. What time tomorrow?
tomorrow same time. So
Same
you,
time in the
yeah,
I think yeah, tomorrow is fine.
Clara,
Yeah, tomorrow works. So we don't have a class, right? It's just the interview.
yeah, it will be the interview.
Okay. All right.
So and I think even Ken is left for the interview. I think he's traveling. So yeah, tomorrow will be,
Ken is on his way coming back to Canada, I believe.
yeah, he told me like he will not be available. Uh, so let's meet on Saturday again. Okay. Until that time, like complete everything which is left. Okay. And you'll be getting more new assignments also. So again, you have to complete them also.
So I know last week we had class Saturday, Sunday, Monday.
Yeah.
Would that be the new schedule? Wednesday, Saturday, Sunday, Monday?
The new schedule is not that, because like last time we did not have the class because like we had to change it because most of them were not able to deploy their static website, right? So again, we will come back to the same schedule, which is Wednesday, Sunday, Monday. So yeah, actually like yeah, it's Wednesday, Sunday, Monday. Okay.
Okay.
So
Okay.
Wednesday, Sunday, Monday, so no more Saturdays?
Yeah, no more Saturdays.
Oh.
Like last time we did it because most of them were not able to kind of like complete the static website deployment. So okay, who joined?
No, I think it's Sunday, Monday by you, Yane. It was Saturday, Sunday by us.
Yeah, yeah, it's Saturday and Sunday for you.
Yes, yes. Okay.
Not Monday.
All right.
Okay. I think Ken joined just now. Hello, Ken. We were about to end the session, but yeah, the recording is there. So, Ken, I did not get your documentation for the uh, static website. Can you upload it to the Google Sheets whenever possible? Yeah, Helen. Actually, the Chromebook is having a problem with kind of like having the AWS server. So we are still trying to figure it out. When we figure it out, we'll give you the whole idea on how to do it. So actually, we don't have a Chromebook also. So that is the problem going on. But yeah, like you don't need to submit the documentation as of now. You have a MacBook? Then you can try it in the MacBook actually.
I tried it in the MacBook and it didn't work as well.
In MacBook, it is not working. Can you show? Okay, can you tell me what is not working? Like, what is the error you're getting?
I have to like try it again, but because I tried it long time. When I tried with my Chromebook, I tried on my MacBook as well.
Okay, at that time,
But
if
this
you,
was,
so Brandon also has a MacBook, right, Brandon?
Yeah,
Okay,
yeah, I do.
so where you are getting the error, like, do you remember?
no, it was
Me?
just, oh, him?
Yeah, like Brandon, you were getting the error in installing something, right? Because you did not install something. That's it, right?
Yeah. When I got to the RDP, I wasn't seeing the RDP client option,
Okay,
but I had to download Microsoft Remote Desktop on the App Store.
okay. Helen, did you download the Microsoft Remote Desktop?
No, not Microsoft.
Okay,
On
yeah,
the MacBook, no.
yeah, you have to download the Microsoft Remote Desktop.
Okay.
Okay, when you are trying again, okay, just send me where you are getting the error, okay?
Okay.
In MacBook, it will work.
Okay.
Okay. So everyone complete their assignment and complete the new case study assignment also. Okay. And before deploying the elastic beanstalk, okay, I'll be giving you a video on deployment, okay? And uh, after you see the video, we will have the class, okay? And again, we'll deploy in the class. So like this, we can have kind of like a already you can even see the video and you can get an idea. And when you come to the class, you'll be having all the things ready and you can directly see where you are getting kind of like errors and we can discuss on that. So is it fine with everyone?
Yannick and Deb, so just a quick question.
Yeah.
Um, in terms of our progress, are we still gonna complete the course at the 4 month mark, or what do we need to do different?
We will be completing it in the 4 month mark. So first 1 month will be slow. That's given because we have to get the foundation strong. So everything is kind of like now spoon feeded. Okay. So when you have the basics ready, then everything can be going very fast. And also like you have to give more time from now on, like you have the basics now with you. So everything will be like given to you and you will be getting assignments and everything. So like everything should be like from now on, like there will be kind of like little strict deadlines because uh the first 1 month or like first few classes, they are always kind of like slow so that you understand things, you get a grasp, you have to grasp the concepts properly. Like let's say I have given a case study, okay, now uh, there is like there is like one CPU core is having 5 gigahertz. Now you know like what 5 gigahertz is, okay? So after this you'll be getting to like you'll knowing what VPCs are, what subnets are and everything. So when you know each and every component of AWS, okay, the next thing that is remaining is just putting them together. So that is the main thing.
Okay, so Yannick, just a quick question. So 5 GB is equals to one CPU.
No, no, like
No.
let's say you're having a see when we are talking about like one so when you are talking about any kind of like core, okay,
Mm-hmm.
what a core consists of. So a core consists of RAM, okay, and so in this RAM, okay, you will have some let's say 4 GB RAM or something, okay. Now a CPU also contains what you call clock speed. Clock speed is nothing but how much information it is able to process in a second, okay. So if it is able to process 1 GB in a second, okay, then that is 1 gigahertz. Okay, now you might have seen several processors are there, right?
Mm-hmm.
So if you see, like, there is i7, i5, i9. Okay, so for each of them there is something called as clock speed. Okay, how much information it is able to process in 1 second, or how many calculations it is able to make per 1 second. Okay, so that is called as clock speed, and it is measured in hertz, so per second. So when we say it's 1 gigahertz, that means like 5 GB in a second. So like even in your laptops, you'll have cores, like some will have 4 cores, 8 cores, and each core will have a speed. So the speed is usually like same for all of the CPU cores. So that's why it's like one CPU core is 1 gigahertz. So so this gigahertz is very important, because if you are increasing the gigahertz, okay, like to 10, okay, that means the CPU core is twice as fast in processing the information, right?
Mm-hmm.
So yeah, so like these are the basics which you have to have in your mind. After that, like AWS is just kind of like having the services where you have to able to combine whatever you have learned and produce result. Clara, is your doubt cleared?
Yeah, no, it's clear now. Thank
Yeah,
you.
because like every service is having the same components, right? VPC and everything. If you are very good at understanding those things, then everything becomes easy. If you are able to put the components together, that's the main thing. Okay. So yeah, please solve the case studies, and please solve all the assignments you are like uh still pending, and just send to us. Okay, and I'll be uploading a video on Elastic Beanstalk before, like from now on we are going to upload a video every time, like before the lecture. Okay, so that you will have kind of like an estimate on what will be happening in the lecture, and you will also have an idea of everything. So is this fine? Will you be able to spend like extra 50 minutes seeing the lecture before the class?
Yes, I think that would be good. Yeah. So that way we watch the video when we're in class. We already know what is gonna be taught, and if we have any question, we prepare it. So when you're in class, we ask those specific questions.
Yeah. Okay guys, please submit all the assignments which are pending. Okay, uh so let's meet on Saturday, your Saturday.
All right.
Okay,
Okay. Thank you.
thank you.
Uh,
Thank you.
yeah.
Have a
Thank
good
you.
day.
Bye.
Bye.